So this is called sometimes data modeling. So we are going to model the data itself. It's not system, it's not the database management. It's just the data itself. It's called the data modeling. So for the data modeling, there are many approaches, methods. So among them, we are going to use entity relationship model. So as we have learned. So entity relationship model is a simple. So we spend a week, then with the practice, you guys can do the entity relationship model. So such a conceptual model, ER model, is used a lot. Not only the database system, it can be used for the engineering, it can be used for the management, because it's a conceptual level design. Even think about when you clean up your room. So you follow the relationship and entities, whether or not you realize that is a ER. So this is the ER modeling. We extend ER modeling, generalization and specialization. So this is called the EER modeling. So enhanced or extended ER modeling. So output of the conceptual level design is the ER diagram. So you should be able to draw the ER diagram, but sometimes if we design the huge the size of the database, so too many entities, too many relationships, you can use the tool like the Irwin software or Workbench. There are many the different software. Nowadays, the modeling tool, modeling software is not only for the modeling, it can be used for the management of the entire project. So if you create one entity, automatically create what? The table in a database. This tool is connected to the DBMS, so automatically create. Also, you don't have to manage the documentation, automatically create the document. Also, if you create sometimes such an entity, it creates automatically some functionality component. So it can reduce the job of the coding and so on. So it can be, so for example, rational rules such as the project management tool include such a modeling also. Okay. And also, another thing is such a conceptual level modeling, it doesn't have to be done by the computer engineer, computer scientist. Instead, so sometimes those who do not know about the computer, they can do the ER modeling. Because more importantly, when you are doing the ER modeling, it's a domain knowledge. Whether or not you understand the database and the domain. For example, if you are building the hospital management system for the database, you should know what is the component of the hospital and what is the insurance, what is the patient management, so on. That is more important. So because of that, the most of the project, they actually hire the person from the consulting company, like the McKinsey or such a Pitney Bowes. They hire such a specialty who are doing such a conceptual level design. They do not know much about them. They know, but they are not expertise on computer system. Instead, they know what is the money flow and what is the finance, because the most important part of the company is the money, anyway, finance. So they are doing such a conceptual level design. Then, however, output of the ER modeling, the conceptual modeling, is the ER diagram. That's as we have seen before. This is not the computer, the model and so on. So it's still far from the computer database system. So we'd like to approach it to the database management system, okay, DBMS. But we one step close to the computer system. It's organized, well organized, but it's not actually fit to the database data structure. So we need to get close to such a computer system. In other words, so this one is organized, but we cannot say this is a structured data. There is no data structure that you learn in your data structure class or the advanced data structure class. So we need to get close to such a system. At that time, we can use the database, the model. Okay? Sometimes it's called the physical, the level database design. Okay? So one step close to this one. So for example, we have the student relation. So, and we have the course relation, and they are connected like that. So, this the database design among this one also, as I introduced, there are many. The network, hierarchical, object-oriented, object relation, but among that we are going to use relational database model. The relational database model. So last class we talked about what is the relation. So relation is what? It's similar as what? Set in the mathematics. The set is a group of what? Element. So because when Dr. Yevko proposed this database model, the main problem was size of data. It's a very large shared data. If you read, you don't have to read the paper, but at least you should remember the title of his paper regarding to the relational model. It's a very large shared data bank. So which means the size was the problem. If we deal with each and every entity, each and every data, like what we have done in the programming language class. So if your instructor gave you the homework or assignment, first you need to identify what? Two things, the algorithm, how to solve the problem, so main logic. And you need to define the variable. Very similar to what? When you solve the mathematical problem solving. So mostly you need to find the equation with variable. If you can find the variable and equation, you can evaluate such an equation and solve the problem. Similarly, so our main problem is how to deal with such a variable data, very large data. So from now on, why don't we consider it as a group? So relation is a group. So we are not going to consider each and every data instead as a group. So to deal with many students as a group, the best way is standardized. So each student has its own characteristic. He is very good at math, but she is good at artistic. But if I consider each and every case, if I can do it, I'd like to. But if I had 60, 100, 1,000 students, it's not possible. So instead, what I'm going to do is I'm going to only consider name, the UBID, and the GPA. That's it. So that is kind of standardized. That is kind of modeling. So relation is kind of standardizing the processing. So we are going to define such a relation as a group of what? Attribute. So our goal is to find the attribute that defines student relation. So that is an attribute. Our goal is to find the course, the attribute, a number of attributes. Or if we have a number of data, there is such a relation defined as what? Group of data, group of tuple, group of row. Such a data, each and every data should have the same format. Name, ID, grade, name, ID, grade. Then finally, we can easily manage such a, no matter how many data we have, we can manage such a data. Management means what? Eventually, we are going to search the data. So that is the main task of any computer system. Long time, our goal is to deal with the number and the data, alphanumeric data. Then, at the time, why do you use the computer? Input and output for the processing computation, then eventually find the data, output, find the output. So your computer should be fast. Your data structure should be fast. Your design model should be fast. If it's slow, don't have to use. So from that point of view, so to search the data. So this relational model deals with very large data. Very large data, but it will be slow because it's very large. So to address that problem, relational model has the constraint. So as we have seen the last time, the three main constraints, key constraint. Key constraint means unique. There exists one key, primary key the first key attribute. Okay, key attribute is a unique. So, for example, UBID is a unique the value, so we can search the data very fast. At that time, we can call such attribute as a key attribute. How many key attributes we can have? As many as possible. UBID plus name, also key. So such a key is called a super key, but we don't need the super key. Only minimal super key. Okay, minimal super key means UBID or SSL, such a thing. So that is the key attribute. However, unique means cannot search null value, right? Null cannot be counted. Null doesn't exist. So if you count 1, 2, 3 null, this is total how many? It's a 3. Okay. Later, when you really select, count such a value, it's a return 3. Okay. So null doesn't exist. The reason why we use the null is standardization during the relation. Name, ID, address. I do not have an address, so it's a different. So to standardize, so we use fake data. It's a null. Okay? So to address that problem, so entity, integrity. To integrate, okay, format, integrity, constraint. So not none value. So key constraint and entity integrity constraint, by combining this is called primary key constraint. So primary key is the most important concept of the relational model. It's a non-null and unique. So if you are taking the certificate related to the database, like the Oracle or such a thing, this is the most popular question. What is a primary key? Primary key is non-null and unique. Okay? So this is the first two. Then third one is we have the primary key with the attribute. Primary key with the attribute. Primary key with the attribute. However, what about for example, student has the department number. So this the major department, computer science, should exist to keep the consistency. So at the time, we need to check the department, the ID. Is exist one. So always the DNO is reliable, depend on the primary key of the department. At that time, this is called the foreign key constraint. The foreign key constraint has the two entity. Okay, so one. So for example, this is employee and DNO. Primary key is SSL, and the DPT is a D number. This is a primary. So always depend on this one. This is a referencing. This is the reference. Don't be confused the arrow. Always every time from the midterm exam when I ask this, the kind of the relational schema diagram, so always confused. Reference, referencing, referenced. Which one? The referenced column should be unique. Okay? So mostly primary. It doesn't have to be primary key, it can be unique. However, mostly primary key. So this one doesn't have to be primary key. Okay? So referencing and reference. This is a foreign key relationship. Sometimes multiple is dual. Okay? Multiple to multiple is a composite. Foreign key is possible. At the time, you can use the parentheses. So foreign key constraint. These three are the major constraints of the relational model, relational database model. Plus, there are more. Even non-null constraint we mentioned, and also for example, our database has the constraint, the condition. For example, all employees, their salary should not exceed the CEO's salary. There can be rule, there can be constraint in our database. This is called the customer constraint, the user constraint. So such a user constraint can be implemented by later. It's called the trigger or assertion. So we will you will learn how to create the trigger. This constraint, if you insert the DBMS, it's already there. So you don't have to create. You can create your own constraint, but function. So such a constraint are implemented in the DBMS. However, such a user constraint, user-defined condition, you need to create by yourself. So we will practice during the exercise later. Okay, so this is the DBMS, the relational database, relational model. Okay, so this kind of diagram is called relational schema diagram. So I asked you the last week to draw the relational schema diagram for the last page of the chapter 5. Do you remember? It's a book, the publication. Okay, so please turn in before you leave today. So it's a practice. Okay, please keep track of your homework. Okay, so you are not the elementary school student. Every class I assign the homework. Okay, if you ignore you cannot get the full credit. Please, I do not ask you the huge bunch of homework. So it takes just 10 to 15 minutes always. So do not expect so second chance or third. I forgot. This is not the elementary school. It's a graduate, even though we have the graduate student. So I believe that you can manage such a responsibility by yourself. So please keep finding, keep checking. So even the GA and me, they remind you, but not always. So please, any pop-up homework or such a thing. So don't expect the second chance. If I forgot, it's okay. Professor Lee allowed the next time. So please, from now on, I'm not going to allow the second chance or third chance. So if I assigned any pop quiz, the schedule, definitely you can follow the schedule. Otherwise, please keep track of your homework. So this is the last week homework. Please submit before you leave. Then with the relational, the database model, then we can create the database. So at that time, we need to use the language of using such a DBMS system, which is called the SQL. So we are going to see such a SQL. The SQL has the two parts, as we discussed at the beginning of semester: data, definition language, data, manipulation language. Data definition language is to create the schema. Okay. Then after we create the table, we are able to insert and delete the data. So database support the CRUD also. Do you remember the CRUD in the data structure class? CRUD, create, C. R, retrieve. Read, you update and delete. So these four operations are basic operations with any kind of data. Update can be replaced by delete and insert. But the CRUD is in general. So for example, if you judge my algorithm is fast or not, in terms of big O notation, you need to check what is the complexity of that for each operation, CRUD. Database supports such as CRUD also. For the create, insert. This is the database terminology. The read, select. The U update is update. And delete is also delete. So these are the data manipulation languages. This one is also the relational model. It suggests this kind of operation. So using this operation, finally we can create the table. Then the user or application can access such a data. Okay, this is the overview of the database design that we discussed so far. What we missed in this process, database design process, is actually this part. We learned about the data model. It's a conceptual level model, logical database model. This one is a relational database model, physical database model. Okay, it's a database model. It's a closed computer, but This is the gap. This is a computer-related model. This is not. So we need to bridge the gap. Okay? We need to bridge between data model and database model. So today, this class, we are going to see how to bridge. In other words, how to create the relational database model from the ER model. So, in other words, how to draw the relational schema diagram from the ER diagram. So, for example, so this is the example of our company database. So hopefully, I hope that you guys memorize this ER diagram. So you do hand drawn, you use the orange software, at least 3-4 times you draw this ER diagram, right? So we have the number of entity and so on. But this is a logical database model, and next this is the physical database model, the relational database model. Exactly the same thing, but this is a database model. So employee relation, department relation. Primary key is underline, and we have foreign key. So from the DNO to the D number and the arrow, like this. Then the problem is we learned each of them, but we do not know how to create this one from this. So today we are going to see how to create the relational schema diagram from the ER diagram. Good news, it's simple. Also, we can just follow the step by step. Okay. Also, it requires practice. It's not very complicated. As you have seen the database design the last 4 weeks, it's not the concept itself is not complicated. The problem is whether or not you practice. So I guarantee if you understand the database course in your mind or brain, you cannot get the definite full credit. So this is my 99% correct my experience. From the student always complain, I understand, yes, you can understand because it's such a concept is not very complicated one. But from the exam, many of the students who fail, they never practice, even homework copy. So it's a 4-year practice. Please follow the step and with it's kind of really the muscle memory unit. When you see this one, this is the entity, this will be what? So you need to follow the step and draw. It doesn't take a really long time. Just always my homework is 10 to 20 minutes. Practice. Okay? So today we are going to create such a relational schema diagram from the ER model. Okay, but as I said before, can you see any similarity between this one and this one? ER diagram and relational schema diagram? Very similar, right? So for example, employee is the name of entity, name of relation. So one of the main reasons why we pick the always ER model for our database model is this one. ER model is very similar as the relational schema diagram, relational database model. As you can see, a lot of them, employee, department, project, dependent. Employee, department, project, dependent. A lot of them already table relation. So it's one of the main reasons why we use the ER model is, ER modeling is, it's very similar, very close to the relational database model. Okay, that is the one main reason. Another reason is very intuitive, the data model technique. So that is the reason this is the most popular way when you are doing the conceptual level design. Okay, so let's start. So please keep in mind that this ER diagram, or please keep the refer your handout. So you have this ER diagram. So let's start with first step. It's a step by step. I'd like to show the first, this is a step. We are going to follow this step, mapping, entity, weak entity, and relationship. Step 3 to 5 is relationship, and so on. So we are going to follow this step. The first step is entity type. So if you remind, the entity type is, for example, employee and their attribute. Some of them, if for strong entity, it has the primary. So first, the entity type is going to be what? Relation. Relation means table. Okay? And their attribute. Attribute is going to be automatically attribute. And key attribute. So strong entity, when we are doing the first step, step 1 is a strong entity. So it has a number of key. So key attribute, we select the one primary key. Okay? Because how many primary key in the relational model? Only one primary key. What about the other attribute, which is not selected as the primary? The other attribute will be candidate key. So we can create the candidate key. Candidate key is if you remind the super key. So from the super key, we can find the minimal super key. So how many minimal super key? 1, 2, 3, so on. We select the 1 as the primary key. Somebody may ask, how do I select? How? How do you select the primary key? Check the application. So one example is, I have a social security number and UBID. If your database application is for the student management or class, UBID is better. On the other hand, this is for HR, the career service. Career service, you need to pay the tax. So social security number can be better, the primary key. So you can select the one primary key, the other is going to be candidate key. Candidate key is multiple or nothing. So it's also useful for search because it's unique. This one, unique and plus none. So this is the first step. So let's convert our the company database. So we have employee. So employee relation. So employee relation has the, for your in mind. So employee has the attribute. So what will be the primary key? Oops. Social security number. So social security number is the primary key, and the other, the B date. Here, name is what? It's a composite attribute. There is no composite concept in relational model. If you remember, when you create the relation, select the one value from domain. So we cannot create the attribute like this. Instead, first name, the middle name initial, last name, like this. So we cannot keep the composite tree structure. Instead, the last name, middle name initial, first name. Then address, salary, and sex. So this is the employee. Similarly, we can do the department. Department, the primary key is the number or name. Which one will be better for the primary key in this case? Name? The number or name? Which one will be better for primary key?
Number.
The number is better usually. Why?
Because it's unique.
Here the name is also unique, so no problem to be primary key. But think about performance. So when your computer, when you process text data and number data, which one will be faster?
Number.
Number is definitely faster. Actually, computer cannot understand text, the alphabet. How does the computer understand the text? ASCII code. We code. Eventually, it will be binary. Binary is a number. So like the A is 2 bytes, 001, 01, 00, something like that. Okay? So eventually, it will be decoded. So it takes a long time. So not long time, but longer than the number. So we'd better keep the number as a key. That is the reason when you see the real database, a lot of them is a sequence number. ID, customer ID, item ID, student ID, something ID. Why? Number is easy to manage and also it's fast. So we'd better select the number. The number. And the name. The name actually can be candidate key. Candidate key, sometimes you can put the underline, underscore, but the dot underscore, but sometimes the parenthesis. Okay, then we will deal with the location later. Okay? Double, the over means multi-value. We will deal with such a thing later. What else? We have a project. Project has what is the primary key? Number and the name. Which one will be better?
Number.
Number, so P number. And P name. And what else? So location. This is a single, so we can create. That's it. So we have 3 strong entities. So we can create the 3 relations. This is the first step. Very simple. One more thing. Naming rule. If you see this one, department D number. Instead of number, we name the number, but we use the D number. Okay? So there's no general rule in the database for naming rule. Okay? Object-oriented concept use the common style naming rule. Okay? Class name, the second letter is a capital letter, and the first letter is like that. And Python use like the underscore name. The Lee underscore, Jongyu underscore, class underscore. But it's not required, it's general. Database does not have such a thing. Instead, database, mostly your project manager will give the naming. So for example, in my case, when I joined the first time, the banking database is a bank, the DBA. So the naming rule has 4 business. So for example, ACCT is account. And I means always the internet. So BNK, so internet banking. And the loan, internet loan is ILON. So there's a group name. It's fixed. We must use this one. Then underscore detail. Account, custom, CUST, like that. Okay? Then if partition P1, like there's a specific naming rule, but it's only for my project. So your project manager will give such a naming rule. This is just the general. But in my class, at least it should be readable, and anybody can understand the meaning of the attribute. Okay? It is true. Sometimes you can create a table name T1, T2, column name C1, C2, primary key PK. This will not be accepted in the exam in your project. Okay? Meaningful name. Please give the meaningful, the attribute, and the variable name. It's really helpful. Think about when you develop the program, but you are in a hurry, so you can create the C1, C2, and A1, A2, such a variable. Please create a meaningful name. Okay, this is the first step. So first step is the mapping regular entity type. Second step is we have the weak entity. Step 2. So weak entity. In case of weak entity, we can create the relation table. However, this weak entity does not have the key attribute. It has only partial. Because of that, we need to use the identify relationship. So depends on to find the full key. So for the primary key, create the primary key with the identifying relation. Primary key of identifying relation. Then one more thing. So first create the relation, their attribute with attribute. And primary key with the identifying relationship. For the identifying relationship, so this one, we can create the foreign key. Okay? So let's see this example. So we are going to create the dependent. It's the name of a table, name of a relation. So to create the dependent, we do not have a primary key. Instead, only we have, as you can see, the name is what? It's a partial key. So name is not enough to be a primary key. Instead, we need to use the identifying relationship SSN. So then this one is the primary key. So we can create the primary key with the identifying relationship, the primary key, this one. At that time, you can create the SSN to differentiate from the SSN of employee. You can employ SSN. It is okay, but SSN is also fine, as long as you understand.
Both are same, right? So why we need to add one more naming convention?
This one?
Yes.
So you can use any name, but to differentiate, okay? This is kind of primary. This one is, we are going to create the foreign key like this. So it doesn't matter ESSN or SSN, but to clarify, we can use the ESSN. So we can create the foreign key with this. Okay? Then the other, like the attribute, what? Sex, birth date, and relationship as the attribute. Okay, so second step is to create the relation from the weak entity. So what weak entity, difference between the strong and the weak entity is you need to create the primary key and foreign key using identifying relationship. Okay, then third step, step 3 to step 5 is for the relationship. We already deal with the entity, but this one is for the relationship. For the relationship, how many different relationships we learn? 2 table, 2 entity, how many different relationships?
One
1
to
to
one.
1, 1 to many,
Many to one.
many to many. So first, which one is easy? 1 to many. 1 to many is so let's deal with 1 to many. 1 to many, for your remind, okay? So this is entity, and so many employee works on
One department.
how many? One department. One department has many employees. It's 1 to many. So employee and department. So in case of 1 to many, we can create 1. So we can create the 1 foreign key. For example, employee. Many employee. So from here, each employee has department number where this employee is working. But we need to check. This one should exist in this one. We can create the foreign key. So in case of 1 to many, we can just create the foreign key. Very simple. But be careful. This is common mistake. Direction. Always reference 1 is the primary key. One side is the primary. That makes sense. We need to find the one specific department. So even I sometimes confuse the direction. At that time, so I always remember this one example. Many employee, one department. So many employee find the specific department information. Okay, so this is the foreign key. What else? So from this example, one to many works for. So foreign key we create. This one is one to many, right? So department, the control, the project. So project has the controlling department. So this one goes to this one. Okay. What else? This is many to many, one to many. This supervisor is one to many. So there is a supervisor, SSN. All employee, each and every employee has a supervisor. Not all of them, but each employee has a supervisor. Their SSN should exist here. So foreign key. So you can create the one to many, one to many, one to many case for this. Okay, very simple. So in case of one to many, we can create the one foreign key. Okay, the next one, one to one. One to one is tricky. So let's see the example: employee and department. One to one is what? Supervisor. Right? The one to one, this is a mandatory, this is optional. One employee is a manager of one department. One department has one manager. So this is a one to many. So like for example, start date. In case of one to one, what is the characteristic of one to one? It's a one to one mapping. It can be identical, right? No other entity will be involved. He and me is one-to-one matching, like the couple. I'm not sure whether US does not allow the multiple spouse, right? So one-to-one. So there's no other person until we die, divorce. It's a one-to-one. So my income can be my wife's income. My wife's income can be my income. But it can be separate, but it can be one-to-one because it's one-to-one mapping. So you can actually file your tax return jointly, right? So it's a kind of the same, the thing. So which means when you deal with one-to-one mapping, there are different options. First option is, because it's a one-to-one, we can combine into one relation. Because it's one-to-one, so we have a husband, wife. Instead, just couple. So merge. So first option is a merge. Second option, we can create separately one and create the foreign key. So two relation with foreign key. So we can create the employee relation and the department relation, then create the foreign key. Third option is we can create the two of them, then another one, then create the foreign key. Two foreign keys. So create the three relation with two foreign key. Let me show you the example of this. So we have the manager, employee, and department, one-to-one mapping. So with the option one, we can create the employee, one relation. Then this one is the SSN, primary key, then all the attribute of this one, and department information where this employee is managing. So if yes, so DNO and D number and the location like that. And also there might be another employee who is not the manager, it will be none. Like this. You can merge, and also we can have the start date. This is the first option. Second option is we can create the two, employee and department. This is the social security number, this is the DNO. And manager social security number will be foreign key, like this. Okay. Third option is we can create the two of them. Then another one, this is the manager table relation. Then their primary key is the social security number and DNO. And this one exists here, this one exists here, like this. Okay? So there are three options are possible. Then we need to select one of them. First, in our case, which one will be the best option? Before that, I'd like to give the hint. First option is good for. These two are actually basically same, one entity, but we intentionally separate. Okay? So there's no other information. It's actually at the time option 1 is best. Option 2 is general. Okay? Two different, but they have the mapping like the employee and department. Third option is if you have a lot of information about the manager itself, like the start date, start salary, start something, or management information. If you have a lot of such additional information about the manager, you can create the third option. In our case, so we have the one-to-one between department and employee. Which one will be best? We can select option 2. Why? There is another relationship works for. If we combine employee and department, we cannot keep the works for, right? We lose the information about the works for. Third one, we have only start date. It's not very complicated, the information. So we can select the option 2, which means create the department and employee already. Then manager, social security number. This one, refer this social security number. So we select the option 2. Okay. 99% is the option 2. 99% of I never seen the option. It's theoretically possible, but mostly create the foreign key. Okay? Foreign key option. Then one-to-one, one-to-many. Next one is many-to-many. In case of many-to-many, so did you practice the workbench or the Irwin software? So you submit the homework. What happened when you create the many-to-many? Anyone who used the workbench? What happened?
It creates another table.
Another table.
Relationship.
And what about the Irwin software? You have an option if you right click, whether you propagate or not. Then why does such a software create the additional entity? Why? So let's see our example. In our example, the many-to-many is project and the employee. We have hours. Okay? Works on number of hours. For example, the Lee works on 1 hour for project 1. James works on 2 hours for project 1. Lee also works on 1 hour for project 2, like that. It's a many-to-many. If we create only project and employee only, where it goes, hours. Can you show the number of hours for each project and for each employee? No way. because it's a combined total number of hours. Total number of hours. So we cannot see individually for each project, for each employee, number of hours. Because of that, many to many case, always like this third option, we create additional, always, many to many additional the relation table. Then primary key of this is the combining the primary key of one, PK1, and primary key of this one, PK2. It's a composite primary key. Okay? Then foreign key. This one should exist, this one should exist. So we create the one additional relation plus two foreign key always. So many to many case. That is the reason when you are using tool automatically create the additional. Sometimes automatic, sometimes you are asked. So in our case, we have many to many here, number of hours. So all attribute. So we are going to create the hours in between. Then primary key of this one is a D number plus P number. No, it's an employee and the project. So employee. So E is a DP number and the ESSN. Then it's a primary key. Then hours. This attribute of the relationship will be here. Okay, then the PNO goes to here. ESSN goes to here. So we can create the two for. Oh, I forgot one thing. Here, one-to-one case. If you create these two relation, what about the start date? Because this is one-to-one, start date either employee or department. However, this start date is only for manager. So we can create the start date attribute on the department side. If you create the start date here, not all employees are manager. So a lot of non we can have. So this one is bad. So then we can create the many-to-many relationship. Okay, let's go back to the step. We did the step 1 and 2 entity, step 3 to 5 relationship, mostly done. The next thing is the step 6. It's a special case. So if you go to this location, we didn't address the location here. Why? One more time. Multiple doesn't allow relation. Relation, when you create the relation, the table, you select one value from domain. It's only one value. Think about the different way. The Dr. E.F. Gould proposed a relational model for what? Managing very large data. In other words, search data very fast. So if you search the item in your room, so you have a bunch of box inside the box. Inside the box inside like the Russian the door. So when you search, you need to open, and it takes a long time. If not, you need to open this box and this box. It's kind of a back and forth. It takes longer time. So relational model does not allow box inside the box. Or multi. Only one value in a box. So open, if yes, get it. Otherwise, no. To speed up. That's the main difference between relational model and object-oriented model. Object-oriented model allows object inside object. Like you can create a tuple. Element of a tuple can be anything, object. But the relational model does not allow such a complicated thing. So that's the good thing and also bad thing. Good means fast and easy to make. Bad thing is not flexible. So because of that, we cannot keep the locations multi-value. Instead, we need to create this. So step 6. Multi-valued attribute, create the one relation. With what? Foreign key. For example, the DEPT location. Then DNO plus location name. Like the HR New York, HR Dallas, HR LA. So this one is the primary key. If you have additional information, you can put address like that. This DNO should exist in the department. So multi-value, you need to create the one relation. Okay? Because of that, when you design the database ER model is simple. But when you create the database model, relational database model, you will see more table. You can realize that 1, 2, 3, 4 entity, but you can see 1, 2, 3, 4, 5, 6, 7. Such a table will be created. That's general. Okay? It's kind of because standardized. And also, we will see later, normalization. Have you ever heard about database normalization? So during that time, we will realize why table is. I expect a 10 table in my database, but eventually it will be 15, 20, like that. During the normalization, we will see. So almost done. So we covered the most of the step. And what about this one? N array. So most of the relationship has the two entity, like the two entity. But we learned it may be possible 3 entities are involved. So supplier, supply, item, to project, like that. In that case, so we do not have such a case. So we will see such a case later. So this is our final. So from ER modeling, we can create the relational schema diagram. Okay? How? By following the step. First and second step is for entity. The 3 and 4 is for the relationship. The other attribute and the N array. So for the step 1 and 2, basically create the relation. Then proper foreign key. In case of weak entity, we need to find the proper primary key. Keep in mind, how many primary key? Only one. So it doesn't make sense. I create the database without primary key. That is not relational model. That is called the bag. B-A-G. Bag means it's a non-unique set. Okay? You put everything. It's a duplicate data inside. Okay? DBMS allow MySQL, Informix, Oracle, they allow bag without primary key, but you cannot keep the consistency of the data. So always the primary. Then for the relationship, basically you can create the relation table with proper foreign key. However, it has the option, especially many-to-many and one-to-one. One-to-one is not critical. Most of the case, option 2. Many-to-many, you need to create the additional table. Because this one is not problem object-oriented concept. But relational model cannot handle such the data. So we need to create this. Step 6 is the same problem. So because it's a relational model, we cannot have the multi-value. We need to create the additional relation with foreign key. Then finally, step 7 is for the N-array relationship. Let's take a look at the example of this. So this is the N-array, the ternary relationship. We can see the supplier supply the item to the project. So 3 entities. So solution is not actually really the same as this one, but mostly the cover the meaning of this. We can create. So we can create the table relation supply. We can create the relation for project. We can create the part. We can create supply, just like this option. Okay, supply entity. Then we need to create primary key and foreign key. Primary key will be S name plus project name plus part number, composite primary key. Then foreign key, 3 foreign keys. So if you take a look at this example, then you can understand. So we can create this one is connected. One primary key. Don't be confused. So it's one primary key and the quantity is the attribute, then there the foreign key like this. This is the most popular way. Most of 99% such a case you can address create the table like this. So we did. It's very simple to follow the step. You can follow the step and create. So also same thing, homework. Please draw the relational schema diagram for the company database by following the step. Check the step by step. Okay. So then your output is like this. It's a handwritten. So by the next week, the Monday, so please. Okay. Then the remainder is extended and enhanced part. So do you remember the enhanced? That is this. For your reminder, how many entity we have here?
One.
This is only one employee, but we have subclass secretary, technician, engineer. Characteristic of the generalization or specialization is super subclass is all attribute in the superclass is common to here. So for example, what is the primary key the key of the secretary? Like that. If we have D here, D is a disjoint. Disjoint means one of this. And O means overlap. It can be secretary as well as technician as well as engineer. And single line means full participation. The single line is optional. There might be employee, none of this. Double line means should be one of this. This is a super and subclass. Then problem is how can we convert this super subclass into relational model? As I said, relational model is very strict. It's not like the object-oriented concept. If you are using the object-oriented programming or the database, it's very simple, right? You can create an employee class, then inherit, then create a secretary class, and also you can create a technician class, then you can create an engineer class. That's it. Database, relational database cannot do that. Okay? So we are going to address such a thing. There are different options. So I already used this. So I'm going to convert this one. There are 4 options to convert such a case. So I'm going to try my best to introduce this option. So first option is you can create, so how many class here? We have one entity, but how many class? 1, 2, 3, 4 subclass. So we can create each class the one relation. Okay. For example, in this case, we can create the option 1, create the employee. With what? Social security number. And first name, last name, middle name initial, and the birth DOB, address, and job type. Then subclass, secretary, SSN is the primary key because it's inherited. However, you don't have to keep the first name, last name, and so on. Instead, only typing speed. And the technician, grade 1, SSN, and this is a T grade. And the engineer, SSN, ENG type. However, where is the name? Where is the name of it? Where is the name of it? We can create foreign key. So first option is one for each class, one relation with what? The foreign key. So this is the first option. When you convert into the relational schema diagram, so this is the first option. Okay? This is the most popular way. You can intuitively understand that. However, we may not keep such a relationship like the secretary, technician, engineer, like that. So second option is focusing on only subclass. Subclass is the relation. There is no foreign key. So which means, so second option is, so option 2 is we can create the only subclass, secretary, the technician, and the engineer. Then SSN is a foreign key. Typing speed. Middle name, initial, last name, first name, and DOB, and address, job time. Okay. Then technician SSN. The T grade, middle name, initial, inherit all of this. We are not going to create the superclass, only subclass. Middle name, initial, last name, and first name, DOB, address, and job time. Same thing, SSN. For this engineer type, middle name, initial, last name, first name, and DOB, address, job type. Only for subclass. Then the superclass will be inherit. What is the main difference between the option 1 and option 2? After you create the super and subclass, if you believe they are the same one employee, one meaning, like the employee, right there, then I think that this one, and we try to specialize. However, if you believe it's not very important, they are separate the business, separate part, separate like this one, then you can focus on subclass. Okay, you can select the option 2. Do we need to create a foreign key? No, they are not related here. So you don't have to create the foreign key. So most of case, the option 1. But if you believe the secretary, technician, engineer, it's a 3 different the part, 3 different business, 3 different applications. They are not much related. No meaning of the employee superclass. Then option 2 will be. Okay. So, but this one is more popular. Then third option is, no, I think all of these are employed. So we are going to create one relation table. So like this. Option 3. So employee. So SSN is a primary key. So we have the middle name, initial, last name, first name, and the address, DOB, job time, over here. Then we are going to create a job type. Then add typing speed, and the T grade, and this one is engineering type. Okay, so for example, Social Security number 111, the lead, and the J, address is Bridgeport, DOB, and job type is this time secretary. Typing speed 100 words per minute, and T grade is not, so none. Engineering type, none, like this. For example, there is another employee. There's the Smith, John. There's a Turnbull, and so on. The type is engineer, and the typing speed, none, because it's engineer. The T grade, none, and the engineering type is the manager, like this. So you can combine all these subclass and superclass into one. Okay. Then add all attribute, but you need to use the job type, subclass type to separate. So this is option 3. Last one, option 4. The one big, one relation, but different thing is, what about the optional overlap? You can have the secretary and technician. Can you represent the secretary and technician here? No way. Okay? So, it's the same thing, SSN, all same thing. Instead of job type, you can ask the secretary, yes or no. Technician, yes or no. And this one is engineer, yes or no. Then this one is the typing speed, and this one is the T grade, and this one is the engineering type. So for example, 111, I am the secretary, yes. You can use Boolean. Then the typing speed 100. Technician, no. This one is none. But engineering, yes. So it's a manager, like this. The difference between the option 3 and 4, option 3 is for disjoint. This one works only for the disjoint. In case of overlap, you can use option 4. Okay? But you may have more attributes, so you should judge which one is better for you. So we have option 1, 2, 3, 4, but among that, we need to select one of them. If your database design is not complicated and disjoint, option 3 is mostly popular. But in case of overlap, you need to use this. Sometimes, if you want to really, it's called later normalized, option 1 can be used. So you should be able to consider one of these options. So next class, we have exercise a lot. So did you create the database, MySQL database? Please do so. Okay. You should be able to connect the MySQL database on the GCP. So next class we are going to start the MySQL exercise lab. So please bring your laptop with the connecting to your MySQL database. And before we start, we are going to have the lecture to some of the example of the converting the super and subclass into the relational schema diagram. So by Monday, you have a homework for your practice. So one page, the hand-drawn, the relational schema diagram for the company database. Okay. Okay, thank you, and please submit the homework